Commercial lighting companies push massive 1,000-watt high-pressure sodium setups. They create an environment so intense, it physically melts equipment that gets too close. Because these systems require industrial-grade power and infrastructure, they establish a high-cost barrier to entry for independent farming. These setups generate massive amounts of waste heat. Managing that heat requires a cascading series of expensive purchases: industrial cooling fans, complex exhaust venting, and specialized climate controls. The result is a constant energy tax. The industrial agricultural complex relies on this manufactured dependency on electricity to keep you tethered to the power grid for your food supply. The industrial model emphasizes raw wattage to keep food production tied to the utility bill, ignoring the fact that such high energy consumption is not a biological requirement. Plants do not consume electrical watts, they consume optical intensity. We can build a $15 grid-independent architecture by hacking specific light spectrums and utilizing passive fluid dynamics. We call this the waterworks concept. It allows us to achieve maximum hydroponic yield without a single mechanical moving part. Survivalism is a strict engineering constraint that forces us to achieve zero-waste biological efficiency. Commercial lighting metrics are designed to confuse. Watts only measure the energy drawn from your wall outlet. Lumens measure the brightness perceived by the human eye. Neither tells you what the plant actually receives. The metric that dictates biological growth is lux. This measures the actual intensity of light striking the plant canopy at a specific distance. As you move the light source away from the target, intensity drops exponentially. A high-lumen bulb is useless if placed too far. Standard incandescent bulbs fail here. They produce damaging heat, forcing you to back the bulb away, driving lux down to zero. Through photomorphogenesis, plants react to specific wavelengths. Isolating the blue spectrum with LEDs in a raft system directs energy into leaf production, triggering explosive foliage growth. Shifting to warm red light signals the plant to transition, shifting the biological response directly into flowering and fruiting. By literally choosing the exact wavelength of our survival, we exert greater environmental control than conventional outdoor gardening allows, and we do it without the massive electrical overhead. Light is the ultimate currency of the natural world. Every photon cast upward toward your ceiling or outward away from the canopy is a lost investment. A DIY reflective hood alters your garden's math. Upward traveling light strikes the parabolic hood and is physically forced downward onto the canopy, inflating the lux value. You double usable intensity without increasing wattage. Base mirrors amplify this, pushing downward light into the shaded lower canopy. This is how you engineer a high-performance system for just $15. You use intelligent optical geometry instead of brute electrical force. During a blackout, standard hydroponic systems have a flaw. They rely on mechanical water and air pumps, making them the first points of failure. We bypass this with a no-pump static build. It requires a single 5-gallon food-grade bucket and a vertical half-inch PVC pipe that acts as a dipstick well. The structural medium is perlite, a lightweight, highly porous volcanic glass that retains moisture. To establish the fluid baseline, you pour your nutrient solution straight down the PVC dipstick until the liquid pools exactly 2 to 10 inches below the perlite surface. Through capillary action, perlite passively wicks the heavy nutrient fluid upwards against gravity, drawing moisture straight to the root zone without a pump. Because the fluid line stops below the surface, the dry top layer naturally traps atmospheric oxygen around the upper roots, preventing suffocation. Mastering this passive capillary gradient insulates your food supply from mechanical equipment failure while maintaining biological balance. Perfect lighting and passive watering will fail if your localized thermodynamic environment becomes stagnant. Homeostasis requires a strict temperature cycle. You target 75 degrees Fahrenheit during the day, followed by a mandatory 10-degree drop at night. Holding a static temperature 24 hours a day will stunt plant development. You must also maintain a humidity threshold between 65 and 70% to allow proper plant respiration. Use cheap analog hygrometers to monitor this, otherwise the plants will essentially drown in the air. This cross-section maps air stratification in enclosed spaces. Hot air pools at the ceiling, while heavy carbon dioxide sinks to the floor, creating dead zones around plants. A low-power oscillating fan physically disrupts these layers, actively blending the room into a homogeneous atmosphere. If the air becomes too dry, you employ a low-tech fallback. Simply place open buckets of wet sand in the room to manually raise humidity. Diligent analog monitoring of these variables is the final step to achieving yields that outpace traditional soil gardening by 30 to 50%. Picture a dark, grid-down room, and inside it, a fortress of efficiency functioning perfectly. This operation relies on 3 core pillars: targeted spectral precision to stimulate growth, geometric optical reflectors to maximize intensity, and the passive capillary action of a perlite water gradient to sustain the roots. By combining these physical principles, you bypass the industrial energy tax on your food supply. The grid is a choice, not a necessity. By mastering low-power lighting and static waterworks, you've opted out of the energy tax on your food. Your garden is now a fortress of efficiency. This is Unearth the History. Subscribe to learn how to turn every corner of your home into a high-yield lab, and hit that like button to keep the blueprints coming.